we are waiting for feedback in case this thing is going to start. So once we hear a magic sound coming out of my laptop, and that's good. Okay, so this is an amplifier. Actually, I'm making a video about at some point in the future, but right now we're just in the middle of troubleshooting, so I figured I might as well do a stream. So this is a Class D plate amp out of a, I believe, DIN Audio subwoofer amp. Don't remember the particular model number, but it's like an off-the-shelf type of a Class D deal, and it's completely exploded itself. I've done a fair amount of work on it already, namely, if we swap to the other camera, I've replaced the Class D switching IC here, which I think had exploded. I'm not entirely sure. This thing is a bit cryptic, since it's got quite a fair chunk of circuitry on the actual power amplifier board, and it has this big magical metal can over back here. So to anyone who's just joining, this is the plate amp out of a semi-cheap subwoofer, Class D audio amp, and it's exploded itself. I've done a fair bit of troubleshooting on this thing already, and today we're going to be replacing the power transistors, and hopefully that's the final step in fixing this thing. So let's just give a brief recap on what's been done to this thing already. Zoom in a bit. That's entirely out of focus. There we go. Let's stop that up a bit. So the Class D switching IC on this board was kaboomed. It had suffered conductive gunk. The black kind, same that EV blog, Dave Jones actually took care of in the KRK monitors. It had turned into water and corrosion, so I've cleaned this up right and proper, replaced all electrolytic caps as well as the rather expensive Class D IC which was hiding underneath it. However, upon doing that, it would still not work. It would just keep blowing the mains fuse, drawing a ridiculous amount of power when it turned on, and that was because the power transistors had exploded after the fact. They were actually okay when I started working on it, so I just replaced the Class D IC, and then the transistors had gone bad sometime during work. So hopefully everything's okay as soon as we get the power transistors replaced. So I've got a few replacements on hand. They are IRF, pretty standard, common European type FETs, IRF 540 N channels and IRF 9540 P channels. If you want to look up the datasheet for this amplifier IC, you can see that it's actually got a P and N channel complementary stage. The name of the power amplifier chip is ZXCD1000. ZXCD1000. So it's a bit of an ancient thing, I think, for a datasheet from 2002 or something. But never mind that. I have, however, goofed this thing up slightly, since I was just kind of treating it as a power supply. I just replaced a couple of these transistors with N-channel FETs, because everything's N-channel anyway. Why would they use a P-channel? But of course, since it's a power amplifier, they are of course going to use P-channels. So I've kind of mixed up which FET goes where. I've actually got no idea, so we're going to have to probe that out, which is relatively easy since there's a diode across the transistors, and as you might know, FETs have an internal diode between drain and source, so if we just might even be able to get it on camera. If we probe around a bit, you can actually see the diode. So this is a P channel, Let's get everything in frame. That's a P channel, and here's an N channel. So the pin out and input control FET is gate, drain, source. So if we check the P channel, we can see we've got nothing between drain and source with a positive lead to right. But on the N channel, we'll have a diode drop. So if we do the other way around with a negative lead to right, pop it away, we've got the opposite diode drop. So if we install the incorrect transistor in the incorrect place, we are going to have a diode drop both ways, while in this power amplifier there should only be a diode drop one way, because else you have a diode drop across your power rail, and that is not very helpful. Not very helpful at all. So let's just get in there and have a poke around. I've fancied up my camera mount here so it's a bit easier to actually adjust, so you guys have a chance of catching some of the action. Let's see. There's not the easiest thing in the world to be your own cameraman. I'm not going to be paying too much attention to the live chat, because I want to get this thing done. So, now we're going to probe for a diode drop across the output transistor. So we've got two pairs of output transistors. We've got PN, PN, or N, or NP, NP, one of those orders. And we'll just have to shove the correct transistor into the right spot. So let's GDS gate drain source, the pointer that way, so gate is going to be the bottom, so we want to measure the two upper holes. Let's get a zoom in. Perhaps we can get a zoom in on that. Slightly, we wait, get the meter entirely out of frame. Okay, that is not possible. That is not possible. Ugh. Ah, that's as good as it's going to get, I think. So, positive in the middle, and negative on the top, and we've got a diode drop, so we will hopefully not see that there. And across that we do seem to have an open circuit. The voltage is just rising and rising and rising. Whatever that is, it's certainly not a diode drop, and if we go the other way, we have a diode drop. So we want the diodes in our switching transistors to be pointing the opposite of these. So if we probe one of our transistors, this is the N channel there, so it's going to go in that way. So we want to have, for the upper slot, we want the diode to be pointing. We'll have a diode to be pointing. What's that going to be? Toward the middle. So we want our anode to be in the outer edge, and that is indeed the case on this one. So let's see if I'm thinking this right. I'm horrible at all this mirror image type dealies. So for the positive probe on the topmost contact here, we should not see a diode drop. Now that's what we do. So this transistor is for the lower slots. Lower slot N channel on this particular amplifier. So let's just install that. Where's my thermal grease? Gob paste on there. Jeez. My thermal grease is getting a bit dry. It's just 3 years old, I can't fathom why. So I'll just poke this into this. I need to clean that up slightly because we have way too much thermal paste in that already. But of course we want to have as fresh paste as possible going in for the best possible thermal contact. Just give it wiping off the worst of the excess. There we go. So this was the bottom one. Now that means our P channel is going on top. The IRF and 9540. That's not going to work. Off you come. Go up with that. Jeez, this stuff is really getting dry. That's odd. It doesn't usually happen. It tends to just separate, but this stuff is really getting dry. All the oil must have leaked out or something. Oh well. Doesn't quite matter. So I'll just poke that in the top slot, and hopefully this is going to measure good. If I thought everything out correctly, which is not entirely. I think I might actually have thought this all wrong. I think this might not be in there properly at all. Diode drop one way. Yeah, no, of course I installed them the wrong way around. Because we've got diode drops going both ways. There's no way this could possibly work. I would probe the original working transistors up there. They're open circuit one way, so we're going to have to switch these around. Oh well. Such is life. So you go to the bottom. I can't believe I messed that up. That's a really silly mistake to make. Of course, the diodes are not supposed to be pointing in opposite directions, because then they're just a short, and no matter which way you put electricity across them. So this ought to work a tad better. I'll just poke the transistors in place. I need to make sure the leads are just long enough. These are made in a bit of an odd configuration where you're not supposed to cut the leads, they just kind of line up perfectly as they sit. Let's see, maybe we can... Okay, no, we're not. We are not managing to get a camera in there. Not at all. But what's the fun in watching me install just the heatsink clamp? That is hardly the most exciting business. Screwdriver over. Alright, let's check the chat. People are saying hello. Hello. Perhaps taking a power transformer might reduce some weight. Sure, but why would you want your powered subwoofer to be lightweight? Hello, hello. Hello, my favourite. Hello, Jono. I'm glad I'm your favourite. So, heating clamp goes on there. Is this okay? No, it's not okay at all. There we go. I'm not a huge fan of having this kind of clamp. Maybe you can see it. If I do that, okay, you can't see it. Can't see it at all, but these clamps are just kind of... this is impossible. My camera angles suck. That's going to be remedied soon enough. These clamps just clamp against the heatsink on one side, with a screw in the middle and the transistor on the other, so half of the force is just clamping against the heatsink. There's not a lot of leverage going towards the transistor, so there's not a lot of pressure on the transistor, which isn't good. You want lots of pressure on the transistor so that they make good contact with the heatsink. Tail Beast says hello from New Zealand. Hello, New Zealand. Isn't it like really late there? It ought to be really late in New Zealand right now. Then again, I have no idea what time it is here, so I wouldn't know. Wet out soldering sponge. Is this fan on? Yes, it's on. We need to actually preheat this board slightly, because the PCB in this thing is very, very heavy stock. It's got a lot of copper, so it requires extra heating, else you just have no shot at actually getting any solder flow, even with a heavy duty iron. I think it's like a 3-layer board, this. Oh no, it's just 2 layers, but very heavily via bonded through, and very heavy tracks all over. Do note when you're doing work like this, always clamp the transistors down to the heatsink before soldering them. Also, if you solder them before you install them up against the heatsink, they are going to be exerting force on the solder joint, since they are getting bent when you clamp them down, and that is very, very bad for the solder joints. I think that's hot enough. Let's just float in with the cheapest solder we have. This is soldering well. Despite the fact I'm using the entirely wrong tip for the job. A very sharp, round tip. There we go. We are going to be replacing the top transistors as well. Even though these guys measure fine right now, they've had huge current flow through them. And I don't want to risk taking out another amplifier IC, because they are reasonably expensive. In fact, very expensive for being Class D amp ICs. Like almost £10 each off of eBay, which is the only place you can even get them. Tailbeast says it's 4:10 AM in New Zealand. Just finished work. Jesus. That is indeed late. Okay, let's just double check the polarity of these transistors before we get to work. 9540 is on top. In fact, I already replaced the IRF 540 in this, so we just need to do the P-channel FET, the top one, and hopefully this thing is going to be good to go. Tweezers. Bad old transistor comes out. Again, these measure fine. It's just that I don't trust them, since we've seen these ridiculous giant current spikes while the amplifier has been malfunctioning way above their rated power. So it's better to just get rid of them. way too much. No, that's alcohol, not thermal paste. Way too much thermal grease on there already, so we're going to have to wash that down as well. I wish I could give you guys a better overview of a working circuit, but it's a bit difficult since this is so vertical. It isn't quite optimal for my camera setup. Someone says, try AliExpress for parts. They have reasonable prices and seem original. I don't think you could possibly buy anything original off of AliExpress. I mean, I do go there every once in a while for obscure things you can just get Chinese clones of, but you don't get quality parts out of AliExpress. That's the international Shenzhen market. Oh, there we go. New transistor going in, or attempting to. Oh, that's not at all as easy as I was hoping. There we go. Poked inside. And we'll just clamp it down. I'm pretty sure I already replaced the 540 there. Let's just compare it to one of my other 540s. Does it look identical? Yeah. Yeah, everything's identical there, so I'm quite sure that's been replaced. Maybe? Yeah, the original ones are different, so well, now we should have all new transistors. Just have to solder the last one in and give this thing a power on test, and perhaps it'll be ready to sing. Perhaps. That's annoying. The transistor's all out of whack. Stand up straight, damn you. There we go. Beautiful. Yeah, that's in there. Reasonably straight. I don't like the maintaining of this thing at all because the heatsink clamps are actually providing uneven pressure on the transistors. There's more pressure on one side than on the other. That's just not a very good design. The PCB layout person didn't have a very good relationship with the parts ordering person. Let's just try solder this without preheating the board and using the entirely wrong tip. Tiny. That is a good tip. This is one of my best tips. The one which came with the iron, actually, it's ancient. But for some reason, very good. It's very short, so the heat is very, very close to the tip, giving it very low thermal impedance, which is what you want. There we go, perfect. Now we should be ready to go. So I might give you guys a shot of the power meter, and we'll go to that camera And I'll just rig this guy to look in a different direction. I will attempt to anyway. Let's see if this is going to work. Come on, you can focus. Oh, come on, focus. That's not going well. Let's try manual focus because I don't think... this is not going well. I'm fiddling with the camera. Focus, MF, closer. That's as close as we're going to get, so... That'll have to do. Right, so let's just use the lamp power supply to power most of this thing. So the way this thing is set up electrically is the transformer has 3 taps. It's got one high power tap there. This is a 50 volt AC tap for the power amplifier, then it's got a plus minus 15 volts rail for everything else, and we don't need to drill in the way. So what I'm going to do is I'm going to use the power transformer to power the logic and the plus minus 15 volt rail for, you know, op amps and stuff, while we are going to use the power supply for powering... God, this place is a dump. For powering the power amplifier. So the power on sequence for this power amplifier is when you turn the power on, it feeds the 15 volts directly to everything, so there's no delayed start. Then after a while it'll tick a relay, and that will provide power to the actual power amplifier. The relay is located between the I believe between the rectifier and the big caps, so it's a bit of a silly setup where the poor relay has to break quite an awful lot of current when it has to charge for 2 big caps of that, which are actually in parallel. This is not a dual rail amplifier, it's a single rail, single 70-ish volt rail with bridge tied amplifiers on the output, so it works like a car stereo, basically a big high power car stereo. And the symptom this thing's had in the past is when you turned power on and it's ticked its relay, it has, let's give us a bit of more zoom, it has this tripod is not in a good mood. In the past, when you've applied power, it's turned on fine, but when it's ticked the power relay, this relay right here, it's just shorted the power rail out. So we'd have a good voltage, good 70-ish volts coming out of the power supply up until the point the relay clicks, at which point the amplifier just shorts out. So I'll just clamp on here, noting that polarity does not matter on this plug since it's AC coming straight out of a transformer. There we go. So we'll just turn this up to like 60 something, 2 amps, sure. And now we'll just make sure we have nothing else connected to the test outlet, and I have a power already on. I just need to turn it off and actually plug the subwoofer in. Jeez, that was clumsy of me. That could have ended badly. I wasn't aware the socket was energized. That is not good. Right, so let's turn power on to the We are waiting for a reconnection. Are we back? Okay. So that was a bit anticlimactic. Something went wrong. But it seems we're back. Good. So it seems to be running fine now. We are actually drawing almost no power from the high voltage rail. I have no idea what happened. The first time I turned it on, I'm not sure what came through to you guys. That was horrible timing. The first time I turned it on, it seemed to short out. But the second time I turned it on, before realizing the stream had disconnected, it seemed to power on just fine. And we've got a slight DC offset of about 6 millivolts, 60 millivolts on the output, so this could actually be working right now. Let's put it to a speaker and see if we can get some signal come through it. Where on earth am I going to get signal from? Well, I've got my laptop. So let's find ourselves a suitable test speaker. For instance, my test speakers. But I want to turn this thing off now while it's actually running, in case we're going to get some audio out of it, which is then going to just explode. I'm hopeful. I am hopeful. It's not drawing ridiculous amounts of power. It's not putting out ridiculous amounts of DC either. So, what do we have? It's on, it's set to full range, so if we just feed this some signal from a laptop, it should be putting out something. Hopefully. I'm skeptical since it did short out once. That's the part where we plug an expensive laptop to. A very questionable piece of electronic equipment. Line in. And we will find ourselves some copyright-free music in my playlist. Public domain. Catapulto. Will this play? It will not play. Ugh. My network is not set up properly on this laptop. That's annoying. It's gonna be N. What? Why are you not? There we go, and it's gonna be to do assets, not assets. There we go. Creative Commons. Open a folder. And licensed, and there's my folder, so let's just add that to our playlist, play catalog. Adding, and now there should be some kind of audio coming through. Let's see. Oh, there's nothing coming out. What a bummer. No sound at all. Oh, now the audio froze as well. But there's still nothing coming out, so the amplifier's still dead. Oh, that's a shame. That's a shame. I was getting kind of hopeful for a sec there, but that hope kind of disappeared when I didn't hear any humming when I poked the leads in. So we still have some issues. let's just start by turning everything off and just starting it up again. So all that goes away. We'll give it a sec to discharge everything, and we'll turn everything on again. And it draws a shit ton of current. The moment the relay clicks, perhaps you could see the current jump up on the power supply there. Bummer! That's a shame. How we killed our outputs again. Have we killed our outputs again? Do we have power in our caps? With 2 volts in there. That's going to take a while to discharge. Let's just put some metal to that. And are our outputs destroyed? They shouldn't be, since we don't get that much energy out of a diode drop one way, open circuit the other. Perhaps I can even be so kind as to show the meter on camera. That is probably appreciated. There we go. So let's just move on. That's open circuit one way, and hopefully diode drop the other. And this is open circuit one way, and diode drop the other. There's going to be open circuit this way, and diode drop the other. Yeah, this is all as it should be. Oh, that's annoying. Let's do some maths and figure out what the exact power supply voltage it's supposed to get is, in case it's just really sensitive to that. So we'll just ohms law it. I've got MISC L on this computer. We want, oh no, let's just use calculator, no need for fancy programs. 50 times 1.41, enter. 70.5 volts. Okay, yeah, our 65 is definitely within spec for that. Oh, that's annoying. That is majorly annoying. And what's going to be causing this? Let's see if I remember how this thing was hooked up properly, in case the relay is in some place where it actually might matter whether or not we're seeing AC from a transformer or DC from the power supply. So we'll just beef this out, see if the rectifier is going straight to the caps. Now the input is not going straight to the caps. One of them is. One of the pins is probably going to be going straight to the cap, since the other one's going to be going, since it's just a single pole relay. Clicking there. Yeah, this one is going to go to the relay there, and this one is going to go to the caps. Yeah, there we go. So there's the relay, which we heard clicking, is between the AC side and the rectifier going to the caps. Is the rectifier in good working order? We're waiting. I want to have way over a volt drop here, else we could have a couple of shorted diodes. Yeah, this is looking fine. Yeah, that's good enough. The other pin. Far that way. Yeah, far that way. And fine the other way, I'm gonna bet. Yeah, rectifier's not an issue. Ah, there's some more logic, horrible trash going on. That's annoying. That is really, really annoying. I wasn't expecting this to be this difficult. What's what chat say? Friskt kopplat, hälften brunnet. Indeed. The best fix for a Class D amp is throwing it out. Hardly. Blew it up already? No. Vacuum cleaners are evil. Okay. I wonder how good our plus minus 15 volt fan actually is. Let's give that a check, just out of curiosity, in case there's something funky going on with that rectifier, or it's overloaded. So it's going to be unregulated. Plus minus 15 is like plus minus 18, plus minus 20. 17 volts, that's fine. The other one, where on earth is the other one? What? This makes no sense. It's in the other direction. Yeah, plus 18. Ah, dick. Making some sparks, ruining my probes. Ah, that was not good for a probe. I don't think anything broke, we just shorted the plus minus 15 volts rail out. At worst with rather rectify, but 17 volts, 18 volts, yeah, it's still fine. Nothing went wrong. So let's check the plus minus 15 volt regulator. So I think there might be, yeah, plus minus 12 volts regulator here. We got two linear regs. That's going to be there. No, that's going to be there maybe. 12. 11.94, yeah. Is either of these on fire? Nope. Is a switching IC on fire? Nope. Do we have supply coming to our little driver board here? I'm curious. Let's just measure across some random capacitor. 2.2 volts. There's going to be all kinds of trash voltages here, probably since 12 volts there. There's going to be 12 volts as well. 8 volts. That's not good. So the part of the board we're looking at is, let's see if we can focus on this. Yeah, we can kind of. So this is the part of the board we're looking at. So these two caps here seem to be across the plus minus 12 volts, and these two ceramics in here also, I think, are across those caps, but if we'll measure those, we've got 12 volts across one of them and 8.7 across the other. Like, just from the symmetrical look of that, you can see how it looks all nice and out of focus. I need to autofocus, please. This very much looks like a symmetrical power rail, so I think we might have some issue on our driver board here. So let's just have a bit of a further probe. So the Class D IC there is brand new. It has been subjected to some abuse, so it could have failed again. Hoping not. I have a spare. Let's just check these op-amp looking things. Let's just probe some random components here. That's at 12 volts. That's like nothing. What's this? That's at 12 volts. And what is this? Nothing. Nothing. 12 volts. I am increasingly curious as to why there's only 8 volts across one of those caps. Do we just get 8 volts into this board? As that the case, let's have a bit of a closer look at this. So we will use the magic of cheapo super zoom cameras to have a very good look. So, can we gather something from this? Can we see what's likely to be an input? Not really. Can't really see anything of this black PCB. Can't really see anything. Oh, that's annoying. Yeah, I'm just gonna zoom back out. That was rather pointless. Let's just probe around over the connector there. See if we can find something that's going to be ground. That's 7912, so with 7812 we can have ground in the middle lug there, so we can just take a small clamp on the... Oh no, I've got better clamps on those. We can just take a small clamp to the negative lead of a multimeter. That's going to give us our signal ground. And we have a good reference for what's supposed to be 12 volts. So now this is basically impossible to get in frame properly. Maybe if I put the meter right there. There we go. Well, that's not too bad. So if I put this on the heatsink of the 7912, we get the input voltage of that reg. And if I put on the input pin of the 7812, we get the input of that. So yeah, that's good. So we should probably see plus minus 12 and a couple of these pins going into this board. That's plus 12.2. 0.2. There's another plus 12. Nothing. 3.8. 3.7. I would expect that to be plus minus 12 coming into this board from how symmetrical everything looks. That could be our issue. So what's on these mysterious ceramic caps? So that's ground 1. That's plus 12. That's plus 8.7. And that's ground. That is weird. Nope. I think I'm going to have to end the stream here because this is getting so diggy and I'm going to have to be referencing datasheets back and forth for a very long time to figure this out. So that is not interesting enough for you guys to watch, I don't think. So I'm just going to check the chat for a sec and then we're going to be ending. Sorry. This was not as easy as I thought. Pop it, pop it. No, we're not going to pop it. Blurry vision. Oh, it is a bit blurry. Oh well. Yeah, can end this. You guys, make sure you enjoy yourselves. Bye.